Hi, I am Mike Segtelli, and I am the practice lead for the .NET Application Development Group here at SPR Consulting. Modern users today expect highly performant applications and websites, so developers must keep performance in mind as a feature when doing their work. The key enemy of performance is latency, which is basically the time delay between the initiation of an action and the response from a server. So what causes latency? It can be caused by a combination of several components. The first is system latency. That is latency that is inherent in terms of working with CPU processors, RAM, disk, operating systems, and things like that. Application level latency is the second layer, and that has to do with external dependencies on other systems as well as the code that was written itself within the application. There's also infrastructure-based latency, and that's the time spent while actually passing data across the network, both from internal server to server as well as external server to client. So why should you care about latency? Initially, it was believed that users could not perceive delays below 200 milliseconds. That has actually been proven wrong. In a joint study by Bing and Google, they were able to prove out that users were influenced by delays as low as 50 milliseconds. So in reducing delays from 1 second all the way down to 50 milliseconds, they were able to see user behavior improve by increased time spent on the sites, increased click-throughs, as well as additional page views. They also had higher user engagement by seeing users actually respond to the applications in 2 seconds faster than initially on the 1 second delay. And lastly, the operators also saw a 2.8% increase in revenue per user when they were able to reduce a delay from 1 second all the way down to 50 milliseconds. So what can be done to address a latency? Well, there are several patterns and practices that can be done to ensure that your application is more responsive. The first is called progressive rendering. Progressive rendering is when a user makes a request and the system tries to respond as quickly as possible to give the illusion that it's being a fast response. Then what can happen is other information can come in later and actually build out the page in phases. The second is to reduce disk I/O. Disk I/O is one of the slowest operations that can occur and typically happens when accessing the database or other file system information. What can be done to speed that up is to actually move data from disk into memory to help speed up those calls so you're not relying on disk operations. And third is to actually address more performative hardware. Spun disks are actually much slower than solid state disks. So in the events when you do have to go to disk, you can actually go to a higher performing hardware as opposed to relying on the spun disk. That will also increase and speed up the performance of the application. While many of these patterns and practices will help alleviate improve performance, the reality is latency is only going to increase with additional factors as the application's rolled out. There's restrictions on your external networks, and as well as bandwidth limitations over mobile networks that could also impact slowness. So you really must consider all aspects of your system from the inception of a project all the way through delivery to ensure that your application is as performative as possible. For a more detailed review of latency and performance as a feature, please visit SPR Consulting's blog and read more there.